Hi, so myself Dr. P. Manikandan, Associate Professor in the Department of Aeronautical Engineering, Institute of Aeronautical Engineering. So today we are going to see the topic types of fatigue and its modifying factors. So what are all the factors affecting the fatigue strength? Say its endurance limit. So already in last class we have studied about that what is fatigue and what is that SN diagram and how we are drawing the SN diagram. So today we are going to see that what is low cycle fatigue, what is high cycle fatigue, and these are all the modifying factors of the endurance limit. So endurance limit modifying factors, size effect, surface effect, stress concentration effects, fluctuating stresses, and Goodman and Soderbergh relationship. So up to the stress concentration effects we are going to see today. So fatigue initially, so just we will recollect that. So what is fatigue? So fatigue will be like generally how many number of cycles in a stress cycles before failure. So how many number of cycles the material can withstand. That is that your fatigue strength. So the cyclic stress will be like in combined, or that it will be like multiple load will be acting on a component. So for that each and every load and stresses one cycle will be considered as a one load cycle. So for that how many load cycles, the stress amplitudes are that stress variation due to the stress variation, for how many number of cycles it is withstanding, that is at your fatigue strength and endurance limit. So now that fatigue generally how it is happening, and that it will leads to catastrophic failure. So first it will be starts with initiating the crack. So for the surface, today we are going to see the factors affecting the fatigue strength, right? So in that the first is the surface condition, that also is there. So surface condition means in surfaces any undulations, any scratches, any notches, or any modulations, different undulations are there means. So what will happen? So always the stress, when any load is acting on the stress, so the stress will be creating the resistive forces. So stress will be always travel in a straight path, right? So now in the same surface, one small crack or any scratches or any undulations is formed. So what will happen? This stresses when it is coming, and it will be creating a stress concentration over the tip area, right? So here what will happen in the tip area, it will be having the creating a more stress concentration. So what will happen? This crack, this is the initiation of the crack. So due to the stress concentration in the tip, it will be the crack will be propagate further. So due to the stress concentration, the crack will be propagate further. Then the third stage, it leads to failure, right? So that is that your general mission. So crack initiation, crack propagation, and failure. So the failure stage will be occur very quickly. Once the crack propagate, immediately the failure will occur. So basic factors causing fatigue failure is a maximum tensile stress of sufficiently high value, a large amount of variation or fluctuation in the applied stress, a sufficiently large number of cycles of the applied stress. So these are the basic factors. So these are the, you can see the image. So here the cracks or scratches are created. Then after that, as I said, so in this, what will happen when the stress is, any load is acting upward. So here the stress acting upward, right? So what will happen? The stresses will be travel in a straight line. So it will be creating a stress concentration over this surface. So this, due to the stress concentration, this crack will be further propagate. The crack will be further propagate. So due to the propagation, then final stage will be the failure. So this is also like a brittle failure only, but without neck formation. So these are the additional factors causing fatigue failure is stress concentration, residual stress, combined stress, corrosion, temperature effect, overload, metallurgical structures. So stress concentration, as I said, when there is undulations or any sharp corners or any notches, any surface conditions in the over the surface, any small scratches or cracks, any undulations are there means, due to that loading condition, what will happen in that undulation, the stress will be accumulate more. So that is the stress concentration. So residual stress is when the load is applied after that. Once we know that within the elastic limit, when there is applied load is removed, then it will be come to its original state. But there will be always some residues. Some residual stress will be backing in the material. So that will be when the further continuous cyclic loading is happening. This residual stress also will be keep on increasing in that component. Then this residual stresses will be affecting the lifetime of the product. Then combined stresses. So when there is a proper cyclic stress, as I said, when there is a proper cyclic stress happen, but we cannot expect that always the component will be experiencing the proper cyclic stress. So it will be having variations. It will be having different variation of stresses, right? So all will be combinedly will be act on the any one component. So that is that your combined stress. So combined stress will be leads to, it will be affecting the your fatigue strength. Then corrosion. So corrosion you cannot avoid. So when there is a in default whatever the component in any environment is working, even that normal air moisture will be act as electrolyte. You know that. So due to that, always the corrosion will occur on that material. So due to the corrosion, it will be leads to again the surface. The corrosion will be occurring over the surface, or internal defects also will be created. So due to this corrosion, the surface will be having it will be not having a smooth condition. Due to that, again the crack initiation and the crack failure will happen. So then temperature effect will be when there is the material component is working in that low temperature condition or high temperature condition. Always temperature with the, it will be materials always react with the temperature. It will be highly resistive with the temperatures. So sometimes it will be having the ductile to brittle transition temperature also will happen. So ductile material will be convert into brittle material. So when there is overload, load is more, then due to that high load, the failure will occur, right? And that is the next one condition is overload only. So overload, when that material can withstand that some load, but it is we are applying that high stress means, already that last class I explained the SN diagram, right? So SN diagram, when you are having a high cycle, this is your low cycle fatigue. So for example, up to 10 to the power 3, 10 to the power 8. So this is that your high cycle fatigue, right? So when high stress, high load is acting, your life cycle number of cycle will be less. When there is stress will be, you are applying that less stress, then your number of cycles will be more. So that is that your low cycle fatigue and high cycle fatigue. So now overload means default, we know that overload means it is a more high stresses. So due to that, your endurance limit or your fatigue strength will be affected. That is that overload. Then metallurgical structure. So materials properties. So materials, each and every materials will be your fatigue strength will be different, and different grain structures will be leads to that. When how the crack it will be, when you are having a coarse grains, when you are having that larger grains, then it will be leads to crack will be more. So avoidance of fatigue damage, you need to consider that cyclic stress state, and geometry, we need to focus on the geometry, avoid sharp corners or that and all. Then material type. So based upon that condition, all the conditions you need to choose the materials, residual stresses, and size and the distribution of internal defects, and environment conditions and temperature. So fatigue strength, so cyclic stress state. So now very few parameters how it is affecting. So cyclic stress state, depending on the complexity of the geometry and the loading, one or more properties of the stress state need to be considered. So such as stress amplitude, mean stress, biaxiality in phase or out phase of shear stress, and load sequence. So stress amplitude, that and all is nothing. So this is that your stress amplitude. You can see the diagram. So this will be your stress amplitude. So sigma A. So similarly for the compression also, similar way, same. This is the your sigma A. Then the range of stresses will be, so this is the your range of stress. So range of stress means maximum to minimum up to what level it is, the structural fluctuation is there. So that is the your range of stress. So this is generally you can tell that it's a sigma max will be from here to the maximum stress where it is acting. That is that your sigma max. Then this is that your sigma minimum. This is your sigma max. Now you see the range of stress is sigma max minus sigma minimum. That is at your range of stress, right? So similarly, next mean stress, you can see here this is the mean line. So from the bottom, this is the mean line. So this fluctuation, how it is happening means always stress will be with respect to time. It will be vary. So stress fluctuations will be happen. So sigma mean stress is sigma max plus sigma minimum divided by 2. Right, that is your sigma mean stress. So that only here the stress amplitude, mean stress, so everything. So this and all will be for the fatigue strength. You need these parameters. So geometry, notches and variation in cross section throughout a part lead to stress concentration where fatigue cracks initiated. So we need to be more careful that in a surface there should not be any scratches or any cracks or any notches or any, to avoid that sharp corners, notches. So that and all you need to consider while you are designing a component. So material type, fatigue life, as well as the behavior during cyclic loading varies widely for different materials. So different materials will behave differently with the stresses. So example, composites and polymers differ markedly from the metals. So cyclic fatigue is caused by repeated fluctuating loads that we know. So that is a low cycle fatigue and high cycle fatigue. So types of fatigue we are categorizing into low cycle fatigue and high cycle fatigue. So low cycle fatigue, I said the cycles will be low. The name itself will indicate that the cycles will be low. In that case, the stress will be high. So low cycle occur under high stress and relatively few cycles. So example, engine panels where that you are where you are attaching the wing along with the fuselage. So there you will be experiencing that high loads due to the all the maneuvering conditions. The wing will be having that highly. It will be experiencing the high stress. So where the wing attaching in the fuselage in that area and all will be experiencing that high load. So each and every time during takeoff and landing, this will be reverse. It will be happen. So that is one cyclic stress will be happening. So each and every time. So for the high stress, it will be lead to low cycle. So that is a low cycle fatigue. And high cycle fatigue occurs when there is a stress will be less. So default it will be the number of cycles will be more. So where you will be having the fuselage skin panels and near windows experience repeated pressurization cycles. So depressurization and depressurization of fuselage during takeoff and landing. So that is it will be experiencing your axial loads on the fuselage skins, but it will be comparatively very less stress comparatively with all other aircraft stresses. So default that low stress, then default you will be having high number of cycles. And corrosion fatigue is fatigue accelerated by surface corrosion of the material penetrating inward so that the material strength deteriorates. So corrosion, it will be default when there is a material is exposed to the air and the normal moisture is of content available in the air itself it is acting as electrode. When there is a two dissimilar metals, that is a corrosion basics. So when there is a two dissimilar metals, one metal will act as a anode, then another metal act as a cathode. Because of that only in the same material you will experience the corrosion. You cannot avoid the corrosion. You can prevent from the corrosion. First, you can extend the lifetime itself. So corrosion fatigue, when corrosion will be acting, that corrosion will be deposited on the other corrosion will be happening on the surface. When the surface on the surface, if it is not smooth, it is having undulations, notches, that and all, we know that it leads to stress concentration. So default the fatigue will happen. Then the thermal fatigue, so it's produced by stress fluctuations induced by thermal expansions and contractions. So the last does not include the effect on material strength of heat. So material will be behave differently with respect to temperature. It will be highly sensitive with the temperature. So for the thermal expansion and contractions, default the material will be lose its strength. So finally, high frequency stress fluctuations due to vibrations excited by jet or propeller noise or the propulsion acoustic sonic or acoustic fatigue. So due to its vibration when the propeller or jet engine is running, so due to that vibration, it will be creating acoustic and acoustic fatigue, sonic or acoustic fatigue. Then the low cycle fatigue, it is for thermal expansion and contraction. So non-isothermal and isothermal fatigue. So isothermal and non-isothermal is nothing with respect to temperature. So isothermal means the condition will be constant temperature. Non-isothermal is the temperature will be varying with the time. So thermomechanical fatigue and the thermomechanical fatigue and thermal fatigue. So thermomechanical is a different temperature will happen because when there is a rotating component or the other component is there, so due to its friction, it will be generating a heat. It will be experiencing the heat. Turbine, so engine rotating components will be experiencing. And thermal fatigue occurs under the influence of internal forces. So internally, when there is a section, So internally you will be experiencing that forces. That internal forces leads to fatigue. That is that your internal thermal fatigue. And endurance or fatigue limit stress is defined as a maximum amplitude of complexity reverse stress that the standard specimen can sustain for an unlimited number of cycles without fatigue failure. So that only it's a endurance limit or your fatigue limit. Up to how many, whatever the load cycles are happening in the component, how many cycles without failure it can withstand. That is that your endurance limit or fatigue limit. So endurance limit modifying factors, the experiment results of endurance limit in laboratory are not matched with the mechanical or structural number. So theoretically always will be having the different values. So when you come to the practical, it will be experienced that multiple modification factors. So here also for the fatigue strength, we'll be having that endurance limit will be modified by the separate different parameters. So that is a material composition, basis of failure, and variability in manufacturing. So different manufacturing methods also will be giving the different strength and different properties of the material. So method, heat treatment, fretting corrosion, surface condition, and stress concentration. And environment, it will be corrosion, temperature, stress state, and relaxation times. So design parameters, design modification factors, size effect, shape, life, and stress state, speed, fretting, and galling. So modification factors. So modification factors, these are all the generalized modification factors. And for the calculations, when you are getting that endurance limit, that will be affecting by the modification factors. For that only, for the when practically when we are taking by using RR Murray rotating beam test machine that we explained in that last class, when we are getting that, that will be multiplied with your all the modification. Then only you will be experiencing your stress endurance limit. So modification factors also called it's a Marine equation. So Marine factors are empirical correction factors used to adjust the theoretical endurance limit of a material to better reflect the conditions of a real world component. So theoretically what we are getting, that is directly, it is not practically, it will be always different. So practically what and all happen, this all the modification factors, surface size, load, temperature effect, and stress concentration effect. So multiple factors will be affect the endurance limit. So factors have been identified that quantified the effects of surface condition, size, loading, temperature, and miscellaneous items. So a Marine equation is therefore written as, so this is that your stress modification factors you can see here. So endurance limit at the critical location of a machine part in the geometry and condition of use when endurance tests of parts are not available. So estimations are made by. So this is that S dash E will be that rotary beam test specimen endurance limit. So from the experiment what we are getting, with along with that you need to multiply the all the modification factors. So this modification factor Ka will be your surface condition modification factor, Kb is size modification factor, and Kc is your load modification factor, Kd is the temperature modification factor, and Ke is the reliability factor. So materials reliability will be there. So Kf is the miscellaneous effects modification factor. Then this will be whatever that you are getting the modification factor by using the rotating beam testing machine for drawing the SN curve. That endurance limit will be affected by this all these modification factors. Then finally you will be getting the endurance limit after applying all the. So that is that your modification factors are Marine factors. So in that each and every factor, one factor. So we will be see how it is affecting. That will be we will be seeing in next class. Thank you. So these are only some reference for this fatigue. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.